In the silent expanse of the cosmos, where darkness cradles the secrets of creation, a new revelation has emerged from the shadowed side of the moon. China's latest lunar mission, a triumph of precision and ambition, has returned with findings that have sent shockwaves through the global scientific community. Not because the discovery was entirely unforeseen, but because it confirms a truth long whispered in the halls of academia and space agencies alike. A truth that reshapes our understanding of the moon, our planet, and humanity's place in the universe. The samples collected from the far side of the moon, a region untouched by human eyes until now, have unveiled evidence of something profound. Materials and isotopic signatures that challenge the very foundations of lunar science and hint at possibilities that could redefine the future of energy, exploration, and even existence itself. Before diving into this cosmic unraveling, pause to reflect on the magnitude of what's at stake. Hit the like and subscribe buttons to stay updated on this unfolding saga. The mission, a meticulously orchestrated endeavor, targeted the South Pole Aitken Basin, a colossal scar on the moon's far side, stretching over 2,500 kilometers and plunging more than 8 kilometers deep. This ancient crater, one of the largest in the solar system, holds within its depths the echoes of a violent past, where cataclysmic impacts tore through the lunar crust, exposing materials from the moon's lower layers, perhaps even its mantle. The robotic probe, equipped with cutting-edge drilling and sampling technology, retrieved regolith and subsurface fragments that no prior mission, not Apollo, not Lunar, had ever accessed. What it brought back was not merely rock and dust, but a revelation that has left scientists grappling with awe and unease. The samples contain isotopic anomalies, high concentrations of rare elements, and traces of volatile compounds that defy existing models of lunar formation. These findings suggest that the moon's history, and perhaps its origin, is far more complex than previously imagined. At the heart of this discovery lies a startling truth. The moon's far side is not just a mirror of the near side, but a distinct geological entity, shaped by processes that may predate the Earth itself. The samples reveal an unexpected abundance of helium-3, a rare isotope deposited by billions of years of solar wind, locked within the lunar regolith. This isotope, scarce on Earth, is a potential key to unlocking clean nuclear fusion, a holy grail of energy production that could power civilizations for millennia without the burdens of carbon emissions or radioactive waste. Preliminary analyses indicate that the concentrations of helium-3 in the South Pole Aitken Basin surpass all prior estimates, elevating the moon from a scientific curiosity to a strategic asset of unparalleled value. But the discovery goes beyond helium-3. The samples also contain unusual silicates and metallic oxides, their crystalline structures hinting at formation processes under conditions not seen on Earth or in previous lunar samples. These materials, still under intense study, could have applications in advanced electronics, energy storage, or even quantum technologies. The implications of this find ripple far beyond the laboratory. For decades, the moon was viewed as a barren wasteland, a desolate stage for symbolic landings and limited scientific inquiry. But this discovery transforms it into a potential cornerstone of humanity's future. The presence of water ice, confirmed in trace amounts within the samples, could be extracted and split into hydrogen and oxygen, essential components for rocket fuel, breathable air, and life support systems. A lunar base capable of processing these resources could serve as a refueling station, slashing the cost and complexity of missions to Mars, the asteroid belt, or beyond. The Moon, once a stepping stone, now emerges as a gateway to the cosmos, a logistical hub that could redefine the economics of space exploration. Yet, this potential comes with a shadow. The nation that controls these resources could hold unprecedented leverage over the trajectory of human expansion into space. What amplifies the global unease is the technological prowess demonstrated by this mission. The probe's autonomous systems, guided by artificial intelligence, executed complex tasks with surgical precision, navigating treacherous lunar terrain, analyzing subsurface layers in real time, and selecting samples based on sophisticated algorithms. This level of robotic autonomy surpasses anything previously achieved in lunar exploration, marking a leap forward in space technology. The mission's success in returning samples from the far side, a region shielded from Earth's view, and electromagnetic interference, required a constellation of relay satellites and advanced communication systems, showcasing a level of infrastructural maturity that has left other space agencies scrambling to catch up. This technological edge, combined with exclusive access to the far side's resources, positions one nation at the forefront of a new space race, one not about planting flags, but about securing the building blocks of a spacefaring civilization. The geopolitical ramifications are impossible to ignore. Space, once a realm of tentative cooperation, is now a theater of strategic competition. The nation behind this mission has invested heavily in its space program, building a robust ecosystem of satellites, deep space communication networks, and robotic explorers. This discovery cements its position as a leader in lunar exploration, with a commanding presence on the Moon's far side. The Outer Space Treaty, a relic of the 1960s, prohibits claiming celestial bodies as sovereign territory, but it remains silent on resource extraction. This legal ambiguity creates a gray zone where technological capability becomes de facto authority. The ability to mine helium-3, process water ice, or utilize novel materials could grant one nation a monopoly over the Moon's most valuable assets, reshaping global power dynamics in ways not seen since the industrial revolutions of centuries past. The South Pole Aitken Basin itself is a geological marvel, a window into the Moon's ancient past. Its depth exposes materials that may have originated in the lunar mantle, offering clues to the Moon's formation, and by extension, the early history of the solar system. The isotopic anomalies found in the samples, particularly unexpected ratios of oxygen and titanium isotopes, challenge the prevailing giant impact hypothesis, which posits that the Moon formed from debris ejected after a Mars-sized body collided with early Earth. These anomalies suggest that the far side may have been shaped by distinct processes, possibly involving multiple impacts or interactions with extraterrestrial materials. Some scientists speculate that the basin could contain fragments from the solar system's earliest days, preserved in the Moon's airless environment. This discovery forces a re-examination of lunar geology, raising questions about whether the Moon is a singular object or a composite of diverse origins. The confirmation of water ice, though in trace amounts, carries profound implications. Water is the lifeblood of space exploration, not just for sustaining human presence, but for enabling industrial processes. Electrolysis could split lunar water into hydrogen and oxygen, creating fuel for spacecraft or power for lunar bases. The presence of ice in the South Pole Aitken Basin, shielded from sunlight in permanently shadowed craters, suggests that the far side could host vast reserves accessible with the right technology. This transforms the Moon into a potential fueling station, a logistical node that could support missions across the solar system. The strategic value of controlling such a resource cannot be overstated. It could dictate who leads the charge into deep space and who follows. Yet the discovery's most unsettling aspect is what it reveals about the asymmetry of global space capabilities. While other nations have pursued collaborative missions or focused on symbolic achievements, the nation behind this mission has built a relentless, centralized program, methodically stacking technological breakthroughs. Its ability to operate on the Moon's far side, a region inherently challenging due to its isolation from Earth's line of sight, demonstrates a mastery of autonomous systems and orbital infrastructure. This asymmetry raises a sobering question. Can other space agencies, constrained by budgets, politics, or competing priorities, close the gap before the lunar frontier is fully claimed? The materials found in the samples, particularly the unusual silicates and metallic oxides, open doors to speculative but plausible applications. These compounds, with their unique crystalline structures, could enable breakthroughs in high-efficiency solar cells, radiation-resistant electronics, or even quantum computing components. Their presence on the far side, in a region untouched by prior exploration, suggests that the Moon may hold other undiscovered resources, waiting to be unlocked by advanced analytical techniques. The nation leading this mission has already begun classifying these materials in secure laboratories, with early reports hinting at properties that could revolutionize industries on Earth and in space. The potential to manufacture such materials in the Moon's low-gravity vacuum environment could lead to a new era of off-world production, reducing reliance on Earth's finite resources. The discovery also ignites a philosophical firestorm. The Moon, long a symbol of human aspiration, is no longer a distant dream, but a tangible arena of competition and possibility. The confirmation of helium-3 in significant quantities brings the dream of fusion energy closer to reality. If harnessed, this isotope could power cities, spacecraft, or even colonies with unprecedented efficiency. Yet, the prospect of one nation controlling access to this resource raises existential questions about equity, cooperation, and the future of humanity's expansion into space. Will the Moon become a shared resource, fueling a collective leap into the cosmos, or a contested prize, deepening global divisions? The answers hinge on decisions made in the coming years as nations recalibrate their strategies in response to this seismic shift. The far side's unique environment adds another layer of intrigue. Shielded from Earth's electromagnetic noise, it offers an unparalleled platform for radio astronomy and deep space observation. The mission's relay satellites, positioned in lunar orbit, enable continuous communication with the far side, laying the groundwork for permanent observatories. These could detect signals from the universe's earliest moments, map cosmic radiation, or even search for signs of extraterrestrial intelligence. The scientific potential is staggering, but so is the strategic advantage. A nation with exclusive access to this quiet zone could dominate next-generation astronomy, quantum communication, or even defense-related signal processing, all conducted beyond the reach of earthly interference. The mission's technological achievements underscore a broader truth. Space exploration is entering an industrial age. The autonomous systems that powered this mission, capable of real-time decision-making, hazard avoidance, and precise sample selection, represent a paradigm shift. These AI-driven tools, honed in the Moon's unforgiving environment, could be adapted for Mars, asteroids, or beyond. They enable rapid, cost-effective exploration without the risks of human missions, giving the nation behind this mission a flexible, scalable model for space operations. This approach contrasts sharply with traditional human-centric programs, which are slower, costlier, and more politically fraught. The ability to deploy robotic fleets, coordinated by AI, could industrialize the Moon, turning it into a hub for resource extraction, manufacturing, and logistics. The discovery's timing is critical. As Earth grapples with energy crises, climate change, and geopolitical tensions, the Moon's resources offer a tantalizing solution. Helium-3 could fuel a clean energy revolution, reducing dependence on fossil fuels and reshaping global economies. Water ice could enable sustainable space exploration, lowering the barriers to interplanetary travel. The novel materials, with their potential for advanced technologies, could drive innovation in fields from computing to defense. Yet the nation that controls these resources will hold disproportionate influence, not just in space, but on Earth. The prospect of a lunar economy, where resources are mined, processed, and utilized off-world, looms closer than ever, with one nation poised to set the terms. The South Pole Aitken Basin, with its ancient secrets, also offers a window into the solar system's past. The isotopic anomalies in the samples suggest that the Moon may preserve materials from the early solar system, perhaps even fragments of other celestial bodies. These findings could rewrite textbooks, challenging assumptions about planetary formation and evolution. The Moon, once thought a simple satellite, emerges as a complex archive, holding clues to Earth's origins and the dynamics of rocky planets across the galaxy. This scientific revolution, driven by the mission's unprecedented access to the far side, positions one nation as the gatekeeper of knowledge that could redefine cosmology. The strategic implications extend to military and intelligence domains. While the Outer Space Treaty bans weaponization, the Moon's high ground offers unmatched potential for surveillance, communication, and early warning systems. A permanent lunar base, equipped with advanced sensors and autonomous defenses, could monitor space traffic, track missile launches, or intercept signals with unparalleled clarity. The far side's radio silence enhances its value as a secure hub for sensitive operations, free from Earth's crowded electromagnetic spectrum. This dual-use potential, scientific in peace, strategic in conflict, fuels concerns about a new kind of arms race, one fought not on Earth, but in the skies above. The discovery also reshapes the narrative of space exploration. For centuries, the Moon inspired poets, dreamers, and scientists, symbolizing humanity's reach for the stars. Now it stands as a battleground for technological supremacy, economic power, and cultural dominance. The nation behind this mission has not just uncovered resources, it has claimed a narrative of progress, ambition, and destiny. Its success resonates in classrooms, media, and public imagination, framing the Moon as a frontier of national pride. This cultural momentum, amplified by the mission's achievements, could inspire generations while pressuring other nations to respond with equal vigor. The economic potential of a lunar economy is staggering. Helium-3 could anchor a fusion-based energy market with applications in terrestrial power grids and spacecraft propulsion. Water ice could support a network of lunar refueling stations, enabling cost-effective missions to Mars and beyond. The novel materials, if producible in lunar conditions, could birth industries that manufacture high-value goods in space, bypassing Earth's gravity and environmental constraints. These possibilities, once speculative, are now grounded in the mission's tangible results. The nation that masters these processes could dominate the emerging space economy, setting standards for resource extraction, trade, and governance. The mission's success also highlights the power of centralized vision. While other nations navigate fragmented priorities or international partnerships, the nation behind this discovery has pursued a singular, relentless strategy. Its investment in lunar infrastructure, landers, orbiters, communication relays, and AI-driven robotics has created a self-sustaining ecosystem capable of scaling rapidly. This contrasts with the slower, consensus-driven approaches of other space programs, raising questions about whether decentralized models can compete in a race defined by speed and decisiveness. The mission's ability to execute complex operations on the far side without human intervention underscores a model of exploration that is both efficient and ambitious. The discovery's philosophical weight cannot be ignored. The Moon, once a symbol of unity, now stands at the crossroads of cooperation and competition. The resources uncovered, helium-3, water ice, novel materials, could propel humanity into a new era of abundance and exploration. Yet without global consensus, they could also deepen divisions, creating a lunar landscape of haves and have-nots. The Outer Space Treaty, silent on resource ownership, offers little guidance in this new reality. The nation leading this mission, by virtue of its technological and logistical dominance, may set precedents that shape the legal and ethical frameworks of space for decades to come. The far side's radio silence also opens speculative possibilities. Beyond astronomy, it could host secure data centers, quantum communication hubs, or even experimental AI systems, free from Earth's interference. These applications, while futuristic, align with the mission's demonstrated capabilities in autonomous systems and advanced communication. A lunar base on the far side could become a technological incubator, driving innovations that ripple back to Earth. The prospect of such a hub, controlled by one nation, raises concerns about access, transparency, and the balance of power in a domain where physical presence equates to influence. The mission's samples also challenge our understanding of the Moon's role in the solar system. The isotopic anomalies and unusual compounds suggest that the Moon may have interacted with materials from beyond the Earth-Moon system, perhaps during the solar system's chaotic early days. These findings could inform models of planetary migration, impact dynamics, and even the origins of life. The Moon, as a geological time capsule, becomes a key to unlocking the history of our cosmic neighborhood. The nation controlling these samples holds not just resources, but knowledge with implications for science, technology, and humanity's self-understanding. The discovery's geopolitical impact is already reshaping global strategies. Other nations, recognizing the stakes, are accelerating their lunar programs, but the gap in capability is stark. The nation behind this mission has built a self-reliant ecosystem, from launch vehicles to orbital relays, that allows it to operate independently. This autonomy, coupled with its exclusive access to the far side, creates a strategic advantage that is difficult to counter. The Moon, once a symbol of global unity, now risks becoming a fault line in a new era of competition. The philosophical questions raised by this discovery are as profound as the practical ones. The Moon, with its newfound resources and mysteries, forces humanity to confront its ambitions and values. Will it be a shared frontier where nations collaborate for the greater good, or a contested domain where power and profit reign? The nation leading this mission, by virtue of its technological and scientific dominance, will shape the answer. Its actions, whether cooperative or proprietary, will set the tone for humanity's expansion into space, determining whether the lunar frontier becomes a beacon of progress or a battleground of division. The mission's legacy extends beyond the Moon. The technologies developed, AI, robotics, communication systems, could transform industries on Earth, from mining to disaster response. The samples, with their novel materials, could drive innovations in energy, computing, and manufacturing. The Helium-3, if harnessed, could redefine the global energy landscape, offering a path to sustainability that Earth desperately needs. Yet, these possibilities hinge on the vision and intent of the nation that controls them. Its lead in lunar exploration positions it to dictate the terms of this new era, from resource allocation to technological standards. The discovery also underscores the power of narrative. By claiming the far side's secrets, the nation behind this mission has crafted a story of triumph and destiny, resonating with its people and the world. This narrative, rooted in tangible achievements, could inspire a new generation of scientists, engineers, and explorers, while challenging other nations to match its ambition. The Moon, once a universal symbol, is now a canvas for national identity, with one nation painting the first bold strokes. The lunar frontier is no longer a dream, it is a reality, forged in the crucible of this mission's success. The samples from the South Pole Aitken Basin are not just scientific artifacts, they are a call to action, a warning, and a promise. They confirm what was long feared. The Moon is a treasure trove, a strategic linchpin, and a gateway to the stars. The nation that holds its secrets stands at the precipice of a new era, poised to shape the future of humanity in ways that echo across the cosmos. As the world watches, one truth is clear. The race for the Moon has begun anew, and the stakes are nothing less than the destiny of our species. If this exploration of the lunar frontier has stirred your imagination, give it a like and subscribe for more updates on the unfolding cosmic saga. Share your thoughts in the comments below. What does this discovery mean for the future of space exploration? Will it unite humanity or deepen our divisions? Your voice matters in this pivotal moment. Thank you for joining this journey into the unknown, and until next time, keep looking to the stars